Hey, I have a quick question right now.
Go to hell. Hello, ladies and gentlemen. This is Enoch Lee making a video for my latest project. I know it's been a while since I've put anything on here. But you know what? I just don't feel like showing you everything. I like to keep some things secret. But anyway, for my 5780 Embedded Systems Design course, this is my final project. It is an oven mole. It's a temperature data logger for putting through ovens, whether it be bread or PC boards, whatever. Right here I have the final board, but it has two boards to it. This is the thermocouple amplifier board. This has two channels for two thermocouples, should you want two thermocouples. The board will accommodate four thermocouples. I know, super exciting. Anyway, so I'm using a thermocouple amp from Analog Devices that turns the output of a thermocouple into a nice 5 millivolts per degree. Now I've got one board populated here. If you look at this guy, here's the amplifier. Got a op amp that works as a buffer for the offset voltage. And I've got a terminal block right here that connects the thermocouple. This amp is nice in that it has the cold junction compensation built in. So when you have these wires come into contact with your circuit, that's another thermocouple junction that needs to be canceled out, and this takes care of it. This is a K-type thermocouple. These chips are actually made to work with J-type, but I didn't have any. But the K-type works just fine, just with the right kind of calculation coefficients. So I have my main board here. Here's a bare one and a somewhat populated one. This board, since it has to go in an oven, it can't have any buttons because it has to go into an insulated case. So I've included an accelerometer here, just working in the tap detection mode, and a buzzer, piezoelectric buzzer. If you look right here, it's just a crystal that gets driven by I/O line on the microcontroller. So when you tap it, or double tap it, it should start logging. I've got the LEDs there for visual. And when you double tap it again, it stops logging. It also has an FTDI UART to USB IC on board that lets you watch. This is going to be work. That lets you watch the values as they are being gathered. So if you look at this, I'm here in front of my computer. Gonna start it, gonna start up PuTTY. I've got a profile already set up, and when you start logging, it starts spitting out values. I know it's probably not 27 degrees, but I'll be honest, this amp doesn't do very well at really low temperatures in its range. It goes up to 500 degrees C. Here's me breathing on it, so it's getting warmer. And you stop it, and say you don't have it plugged in while it's doing the logging, just type a D, and it automatically downloads all the data through the UART. Then in case you have a really big data set and you want to stop it, you hit S. So there's my project. This uses the MSP430 FR5969, or the Wolverine. It's their brand new architecture with 64K of FRAM. I'm using it because of the FRAM's capability to be written like Flash, but with a whole lot better capability and longevity. So instead of using a SPI Flash IC, I just use the FRAM inside. My program's only 8K, so that gives me plenty of space for data logging. Anyway, Hope you like this.